Hello everyone. We are going to present on the topic residual analysis. As we know that a residual is a difference between a variable's observed value and the variable's predicted value. In regression models, a residual measures how far away a point is from the regression line. As we look into the residual analysis, the residuals are used to assess the validity of a statistical model. The model is considered a good fit if the residuals are randomly distributed.
Next, we want to discuss about the residual plot. A residual plot is a scatter plot in which the x-axis represents the independent variable or the actual value of the dependent variable or the predicted value of the dependent variable, and the y-axis represents the residual based on the regression model. Next, we have the characteristics of the good residual plot. First character is randomness. Yet the residual should be randomly scattered around the zero line with no obvious pattern or trends. If there are patterns in the residual such as curve or a fan shape, this indicates that the model is not capturing all the important information in the data. The next character is symmetry. The distribution of the residual should be symmetric around the zero line. If the distribution is skewed, this suggests that the model may be biased and not accurately predicted the data. The next characteristics we have constant variance. The spread of residuals should be approximately constant across the range of predicted values. If the spread of the residual changes as the predicted value changes, this indicates heteroscedasticity, which can lead to biased estimate and unreliable inferences. The next characteristic is no outliers. Outliers are extreme values that have a disproportionate influence on the regression result. A good residual plot should not show any outliers that significantly deviate from other residuals. The next characteristic we have is the normality. The distribution of residuals should be approximately normal. If the distribution of the residual is not normal, this can indicate that the model is appropriate for the data or that the data can be needed to be transformed. And the overall good residual plot should be provide evidence that the model is accurately capturing the pattern if the data and that the assumption of the regression model are being met. The next we have assumption. The first assumption is linear relationship between independent and dependent variable. The mean of error should be zero. Error should be normally distributed, constant variance of error, and there should be no autocorrelation and no multicollinearity.
So here we gonna talk about the first assumption, independence. The linear regression model assumes that the residuals or the error terms are independent and no visible patterns exist. It means that their pairwise covariance is zero. If the error terms are not independent, then the uniqueness of the least square solutions is lost and the model is not considered good fit. Here we can see the residual plot for the independence, that there is no certain patterns for the variables. So you can see like it's the variables in a zigzag way and all that, and also with the outliers. The second assumption is normality. Y values are normally distributed with a mean of 0 for each x. The residuals are normally distributed with a mean of 0. Here, if the model is normally distributed, then it implies that the model is not able to explain the relationship among the features in the data. Here we can see the graph, the variables are on the straight line. There is no, like there is a pattern, the variables are only on the straight line. The third assumption is homoscedasticity. It is the constant variance assumption. The errors or the residuals is the constant across the values of the target variable. Here it means that it follows the same variance across the target variable values. You can see here in the graph that there is a difference between the homoscedasticity and heteroscedasticity. Here the variables and the predicted value are in the straight in a, like a straight line strip, and in the second graph you can see the variables are splitted over in a wide range. Thank you so much.